Okay, so here we have a cup with water, and I'm gonna add some food coloring to make a solution. Okay, so I'm gonna add a couple of drops of food coloring. Let's add 2 drops. 2 drops. Okay, so here I made a solution with water being my solvent and the food coloring being my solute. I'm just gonna stir it around with my fancy chemical instrument, a pen. And now we see that we have this green color, right? So what I'm gonna do is I'm gonna make a dilution. I'm gonna dilute this solution. And one way that I could dilute the solution is by adding more solvent. Okay, so I have here another glass of just water. I'm gonna add more water to my solution. And now I have diluted my solution. Remember that concentration, right? It was the amount of solvent dissolved in the solute. So the amount of food coloring, which was 2 drops, in the amount milliliters or in liters of my solvent. So I added more water. Now I have more solution, right? Because I added more water. Now I have more of the solution. So my volume changed. My concentration also changed, right? Now this is less concentrated. I have less solute per water. I have less food coloring per water. That's why the solution got a little bit lighter. But did the amount of solute change? Did the amount of food coloring that I had in my solution change? No, because I did not add any more food coloring, nor did I take food coloring out. So whenever I make a dilution, right, and this was a dilution, I diluted my solution. Whenever I make a dilution, the amount of solute does not change. So you guys have to keep that in mind. The amount of solute, the moles of solute in a dilution do not change. Okay, so today we're going to finish Unit 11, which is solution. And today we're going to talk about making dilutions. So what is a dilution? Okay, so diluting a solution reduces the number of moles of solute per volume. So it reduces the molarity. It reduces the concentration. But the total number of moles of solute in solution does not change. So remember that in a dilution, just like I showed you with the water and the food coloring, a dilution is where you take a solution and then you increase the amount of solvent. So you dilute it, you water it down. If we're talking about water as a solvent, you water it down, but you do not add any more solute. Okay, so the solute stays the same. The amount of solute stays the same, but the solution, the volume increases and the molarity decreases. Okay, so if you wanna, let's say you make salt and water, you make salty water. Let's say you add a lot of salt and now it's really salty, and you wanna dilute the solution. What you're gonna do is you're gonna add more water. By adding more water, you're diluting your solution. You're making it less salty. You're decreasing the concentration, the molarity, but you're not changing the amount of salt that you have in there. What you are changing is the amount of solvent that there is, the amount of water, but not the amount of solute. So the moles of the solute stays the same. Okay, so moles of solute before dilution equals the moles of solute after dilution. So the moles of the solute, the amount of salt that you have in your salty water, or the amount of green food coloring that we had in our food coloring water solution, stay the same before and after the dilution. What is going to change is the molarity and your volume. So how much solution you had, right? Before dilution, you're going to have less volume. After you add more water and you dilute the solution, you're going to have more volume. Remember that molarity, so concentration, is moles of solute divided by liters of solution. So molarity concentration is how much solute you have dissolved in your total volume of solution. If we rearrange this equation so that we have moles equal, we have that moles of solute equals molarity times liters of solution. So if you want to find out how many moles you have, right, what you're going to do is you're going to multiply the molarity, you're going to multiply the concentration times the volume, times the liter of solution. Since in a dilution, the number of moles of solid does not change, but the amount of solution and its concentration does change. So what we're going to do is that we're going to get our molarity equation of molarity equals moles over liters of solution. We're going to solve for the number of moles, so we're going to use this equation, that moles equals molarity times liters of solution. We're going to get this, molarity times volume equals moles. And what we're going to do is, since the moles before dilution equals the moles after dilution, we're going to come up with this formula that says moles of solute equal molarity of my initial constant solution times the volume of my initial solution equals the concentration or the molarity of my diluted solution, of my final solution, times the volume of my final solution, of my diluted solution. Okay, so we have this equation that is M1 times V1 equals M2 times V2. Again, where M1 and V1 are the molarity and the volume of your initial solution, so the solution that we started with, the solution that we started with before we added water, the concentration and the volume, and M2, V2 are going to be the concentration and the volume, the molarity and the volume of my diluted solution. So now I would have to calculate my new volume. So I added more water, so my volume increased, and my concentration is going to decrease because I added more water. I diluted it, so now it's not as concentrated. So we're gonna use this equation, M1 V1 equals M2 V2, in order to calculate the molarity or the volume of either my initial solution or my diluted solution. Okay, so let's do our first example. Before reading it, I'm just gonna suggest for you guys to write the equation, leaving a lot of space, because as we're reading it, or we're gonna read it once and then we're gonna decipher what these numbers mean and where they go, so that we could write the numbers right under each variable, so that we could quickly calculate it. So remember that the formula is M1 times V1 equals M2 times V2. Molarity times the volume of my initial concentration solution equals the molarity times the volume of my diluted solution. Okay, so there's going to be a couple of key terms that you have to look out for. One is diluted. This is going to tell you what is the initial solution and what is the final solution. Another word that is not in this problem, but that you might see in other problems, is called stock. Stock solution. So a stock solution is going to be my original solution. A lot of times in chemistry, we could buy solutions. We buy solutions, and these are called our stock solution. So having one solution in the lab, and then we get that stock solution, and we could dilute it or make it more concentrated depending on what experiment and what we need. The reason that it's important to have stock solutions and not 100 different solutions for different concentrations, because one, that will be a lot of money and it'll take up a lot of space. So by just having something that we call a stock solution, so it's one solution, one concentration, and then we dilute it. So we would, let's say we're doing an experiment that calls for a more diluted solution. We could do M1 V1 times M2 V2, see how much is it that the experiment is asking us that we need, so how much we need. That will be volume 2, and then we could dilute it by just adding water to the stock solution. Okay, but back to the problem. It says, how many milliliters of aqueous 2 molar magnesium sulfate solution must be diluted with water to prepare 100 milliliter of aqueous 0.4 molar magnesium sulfate? So there's a lot of words in this equation. There's a lot of numbers, 3 of them to be exact, but we have to decipher what is it that they're giving us, what is it that they're asking us to find, okay? Which information belongs to the initial solution, which information belongs to the final solution. So if we read it again, it says how many milliliters. The first thing that they're asking us is for how many milliliters. Remember that milliliters or liters, that they're talking about volume. Okay, so they're gonna ask for either volume initial or volume final. They're asking for volume. So how many milliliters of aqueous 2 molar magnesium sulfate solution must be diluted? So what you see how this says diluted? That means that we're gonna get this solution and we're gonna dilute it with water. So this two piece of information, this volume and this concentration, belongs to my initial solution. Okay, so volume, that's what they're asking us for. So I'm gonna leave it as V1 because that's what they're asking us for. And concentration of my initial solution is 2 molar. 2.00 molar equals, so must be diluted with water to prepare. So we're gonna be making something. Whenever it says to prepare this type of solution, that means that that's gonna be our final solution. This is going to be the diluted solution. Okay, so our diluted solution is going to have a molarity, a concentration of 0.4. Notice how the concentration decreased, and it's going to have a volume of 100 milliliters. Okay, very important thing to note here. So in the previous problem, when we were finding molarity, we had to change these milliliters into liters. Here, it does not matter. So in these type of problems, it does not matter if my volume is in milliliters or in liters. What it does matter is that both of my volumes have to have the same unit. So if one is in milliliters, the other one also has to be in milliliters. If one is in liters, the other one also has to be in liters. In this case, the question is asking us for milliliters, so we can leave it as milliliters. Okay, so now all I'm gonna do is here solve for V1. So the first thing I'm gonna do is I have 2 times V1. V1, I'm gonna treat it as a variable X. Multiply by 0.4 times 100. So the first thing I'm gonna do is I'm gonna isolate V1 by dividing both sides by 2. Okay, here this 2 goes away. Here, the units, molarity, cancels each other out, and you see that the only unit left is mLs, milliliters. That's what the question is asking us for. So I'm gonna do V1, so my initial volume equals 0.4 times 100. Let me get my calculator. 0.4 times 100 divided by 2 equals 20 milliliters of 20 milliliters. Okay, so that's my final answer, 20 milliliters. So I would add 20 milliliters of my 2 molar magnesium sulfate solution, add water until that 20 milliliter reaches 100 milliliter, and once I've added enough water to reach 100 milliliters, my new concentration is going to be 0.4 molar. Okay, so our second example says 100 milliliters of a 0.3 molar copper 2 sulfate solution is diluted to 500 milliliters. What is the concentration of the diluted solution? So once we've read it, remember we're going to write our equation. M1 times V1 equals M2 times V2. Now we're going to reread the question, highlight the information about the initial solution, the concentration and the volume of my initial solution, and my concentration and volume of my diluted solution, and what is it that they're asking me to find. So it says 100 milliliters of a 0.3 molar solution is diluted. Again, key term here was diluted. If this solution is diluted, that means that this is going to be the volume for my initial and the concentration for my initial. Okay, so my 0.3 molar is going to be my M1, my initial molarity, 0.300 M, times my initial volume is 100 milliliters. equals, okay? Notice how, so initial. So it's diluted to 500 milliliters. So this diluted to 500 milliliters. That is going to be my volume, my final volume. 500 milliliter. What is the concentration of the diluted solution? So what they're asking me to find is the diluted solution, the concentration of my M2. So they're asking me to find M2. Okay, so notice how my volumes both have the same unit. I do not have to convert it into liters like I did when I was trying to figure out molarity. I could leave them like this because essentially they're going to cancel each other out. So as long as they're the same unit, I do not have to switch them. Let's say this was liters and this was milliliters, then I would have to change them either to both liters or both milliliters. Okay, so now to solve for M2, for my final concentration, I need to isolate it. So what I'm going to do is I'm going to divide both sides by 500 milliliters. They cancel each other out here. Whatever I do to this side, I must also do to the other side. 500 milliliters. Notice how the milliliters units cancel out. That's why it doesn't matter if it's in liters or milliliters, as long as they're both the same. So now I'm just going to get my calculator, do 0.3 times 100 divided by 500 to get 0. So M2 equals 0.06 times 100 divided by 500. Yeah, 0.06. And what units are going to be? M. Notice how the only thing that's uncrossed is big M, molarity. And it also makes sense because we're looking for the concentration of my final solution. So 0.06 molar CuSO4. Okay, and that is my final answer. So to do the third example, remember that the equation is M1 times V1 equals M2 times V2. So initial molarity times volume equals final molarity times volume. Okay, so it says, what is the molarity of a solution of ammonium chloride prepared by diluting 40 milliliters of a 2.5 molar ammonium chloride to 2 liters? Okay, so we're going to read it again because it's a lot of numbers here, there's a lot of words. We're going to read it again and decipher what it says. So the first thing it's asking you is, what is the molarity of a solution? Okay, so they're asking you for molarity, M. Either molarity of the initial or the molarity of the final. Let's keep reading and see. So what is the molarity of a solution of ammonium chloride prepared by diluting? Prepared by diluting. So in this question, are they asking you for the initial molarity or the final molarity? Saying that you're looking for the molarity of a solution prepared by diluting this solution. Okay, so in this case, they're asking you for M2. Okay, they're asking you for M2. They're asking you for the solution, for the concentration of a diluted solution, of a solution that you're gonna make by diluting something. Okay, so this 40 milliliters and 2.5 molar, that belongs to my initial. So by diluting, so that means that I'm going to be diluting 40 milliliters of a 2.5 molar solution to this new volume. Okay, so this new volume is going to be my volume 2. So 40 milliliters belongs to my initial volume. This concentration, 2.5 molar, belongs to my initial. They're asking me for the concentration of my final solution if I dilute it to a volume of 2.00 liters. Okay, now here I wrote everything under each variable, but I noticed one thing. I noticed that here I have milliliters, and here I have liters. So I cannot do that. It doesn't matter what unit they're in, but they have to both be the same unit. So I could either turn this 2 liters into milliliters, or I could turn this milliliters into liters. It doesn't matter which one I do, they're both gonna be the same. Okay, so what I'm gonna do is I'm gonna turn this milliliters into liters, because we haven't done an example using liters, which again, it doesn't matter. You could also turn this into milliliters. It's completely up to you. So I'm gonna turn this milliliters into liters. Remember that you could either move the decimal 3 times over to the right, 1, 2, 3, or you could do, okay, I have 40 milliliters. I need to turn that into liters. I know that in 1 liter there are 1,000 milliliters. Okay, the milliliters cancel each other out. I do 40 divided by 8,000, and it gives me 0.04 liters. Okay, so now I'm going to rewrite this whole thing, but instead of writing in milliliters, writing it in liters. So I have 2.5 molar. My new volume in liters, 0.04 liters, equals M2 times 2 liter. Okay, so to isolate M2, I'm going to divide both sides by 2 liters. Notice how the liters cancel each other out. So now what I'm going to do is I'm going to get my calculator. 2.5 times 0.04 divided by 2, 0.05 molar. Okay, so example 4, the last problem says, a 300 milliliter sample of ammonium nitrate solution produces a 0.186 molar solution when diluted with 50 milliliters of water. What is the molarity of the stock solution? Again, remember that stock solution, that is our initial solution, okay? So what is the molarity of the stock solution? This word stock means our original. So again, I'm going to write M1 times V1 equals M2 times V2. So what is the molarity of the stock solution? That means that they're going to be asking us for M1. Now we need to find out the rest, which it has to be given to us. So let's read it again. It says a 300 milliliter sample of ammonium nitrate solution produces. Again, this is another key term. Produces, diluted, stock. Produces a 0.18 molar solution. So that means that this volume refers to our initial volume. Okay, so 300 milliliter sample of an ammonium nitrate solution produces a 0.18 molar solution when diluted. That means that this is our initial volume. 30 milliliter is our initial volume. So when we dilute it, we're going to get a solution that has a concentration of 0.186 molar. So this is going to be our final molarity or final concentration. So produces a 0.186 molar solution when diluted with 50 milliliters of water. Now, important, okay, because this question, it's worded kind of differently from the ones that we've been talking about, and it's a little bit different. So it says that it's diluted with 50 milliliters of water. It is diluted with 50 milliliters of water. Okay, this 50 milliliters, it is not our final volume. What this is saying is that we had a solution, right? We had 30 milliliters of a solution. We're gonna add 50 milliliters of water until we get this concentration. So we need to figure out what is gonna be our final volume. Okay, and this is gonna be very easy. So to find our final volume in this specific problem, so if I draw a little picture, let me draw a little picture here. We have a cup, or graduate a cylinder. And we have 30 milliliters of our stock solution that we do not know its concentration. We're going to add 50 milliliters of water. So we add, let me do it in a different color. We add 50 milliliters of water. What is going to be our final volume? It is not 50. It is not 30. So we had 30. We added 50 milliliters of water. Our new volume, our final volume, is going to be 30 milliliters, which is what we had, plus the 50 milliliters that we added, 80. Okay, so our final volume is 80 milliliters. And I got that by adding my initial volume plus the amount of water that we added. Okay, since it said that we added 50 milliliters of water. It's telling us how much water we're adding, not our final volume. Okay, so this is a special case. So whenever it says the amount of water that you're adding, you're going to add the amount of water plus your initial volume. So now to solve for the concentration, again, we're going to divide. Notice how both of my volumes are in the same unit. So that is wonderful. We do not have to do anything to them. We don't have to convert them. So to find the concentration, we're going to divide both sides by 30 milliliters. Here they cancel out. We have initial concentration equals. The units here cancel out. That's why we want them to be in the same unit. And then all we have to do is get our calculator and do 0.186 times 80 divided by 30 equals 0.496. The only unit left uncrossed is big M, which makes sense because that's what we're looking for.